on the way to Vizag. So there is slight delay. And now in this session, we'll continue our program. And without taking much time, I request Shri Uninayaji, the Vice President Works, to please come and sum up the today's celebration so far. Shri Uninayaji.
Good evening, everybody. Respected Mr. Thiru, Mr. Suri, and the entire team of JKO. It's indeed a great privilege for me to come and speak on this occasion. Now that I just brought the summing up of that, before that, I would like entire people to give a big round of applause to Mr. P.K. Suri and his team for doing a wonderful arrangement. I had come here about a month before to summarize this. That time itself, I think the 3-day program, I think they have worked for at least 3 months. I think about 2 to 3 months they have worked in this making about the infrastructure and doing it. And I think it's a great work, sir. It's very nice to have this. Now, about summing up the session, I think Harshpati ji had taken up in detail the entire manufacturing, automation, and also the manufacturing 4.0. It's a great platform in which the whole industry is working, right from manufacturing 1, 2, 3. I think he explained it very nicely. Actually, I had written down these points and come actually. And that's what I was telling after Smita and Mr. Rashpati spoke. There's very little for me to speak. But definitely I have to do justice to this topic. Now, about this manufacturing this coming, I would like to take Mr. Warren Bellis quote that factory of future will have only 2 employees, a man and a dog. Man to take care of the dog, and dog to see that no one touches the machine. Dog will see that no one touches the machine, and then man will take care of the dog. This is very symbolic when they tell that. Or what is the mean is that we will see lesser and lesser people in the plant. Automation doesn't mean that you reduce people actually. It actually changes the role of the profile of the people. That's why when you go in for an automated plant, you require a different profile of that. I'll be very happy to say that generally we talk about factory, we talk about workmen, not because of the different category of workmen, it's because of the different job profile of the workmen. In general, we don't have workmen at all. In general, we don't have workmen. We only have engineers. So there are ways and means in which we can get into that, and we have got in that step. I think it's a great topic. Both Mr. Naveen Sharma and his team has taken, and it's a very relevant topic. And for this topic, I think it's a very relevant place we are taking up, because this plant has got one of the most modern automated plant with robotics, and also it has to show the history. It has got almost. I could hear 1962. The other plant is 1960. Almost my age. Okay. The other one is so it's a great movement for us. And coming back to what Mr. Naveen Sharma touched, I think it's a very sensitive point what we touched. That is the conference. We should take away something. Okay. And we should be able to incorporate that. There is a lot to incorporate. See, it's all our attitude we keep on to that. Definitely, when tomorrow when you see our Chennai plant's presentation, our plant is only about 2.5 3 years old. But the automation they will be showing in 2 parts. One, automation which has been done on the design. That is when vision was put on the plant. We have designed the plant, so you will see automation on that. The second part is automation. After the design, when people started working on that, what automation we did. See, that's the platform. The initially when the platform has come, and then the next platform starts coming in. Mind starts exploring and getting it. And definitely, I'm sure that there is a lot Chennai can help you all. In my team, we have got from the mechanics, from the electronics and electrical, from the production, and from the IT. Okay, this all definitely are the part and parcel of that. So definitely do share with them, and also definitely Chennai is there to help, and definitely we also will be asking for a lot of help on this. Now coming back to this 4.0 what Mr. Nanaji has touched upon, there is a very classic statement by a German manufacturer. They are a very historic manufacturer. They have got a symbol of a man with a hammer hitting a metal piece. That's the logo of the company. And he is telling that before I pass away, I want to change the logo. Because the next generation will ask, what is that man doing? What is that man doing? Because they will forget that once upon a time, a hammer was used by a man to hit a piece of metal to shape it. People will forget that. So that's the power of automation coming up. And definitely we in JKO, all the plants of JK, and definitely in all across our country, we are into that process. And definitely we will benefit a lot into that. And what does automation give? I get very vouch upon that because I'm seeing it. It doesn't just give a new automated machine. It gives something very high productivity. For example, Chennai tire plants productivity is 45 kg per man hour. The next one in India is 38. Next one in India is 38. So that's the gap. And 45, and the old plant to take it's about 12. So about 12. So 12 to 48 is a big gap. Not only that, it gives additional benefit about consistency. When human interference is there, there is a lack of consistency. Good or bad, I'm not talking consistency. Consistency, then reliability, very reliable. When they work, the reliability factor goes down. And third is, the most important is quick changes. With the automated factory, you can do quick changes. Changes in technology, changes in customer need, changes in the cost of customer or in raw material requirement, it can do. And I did thank Mr. Suri and Mr. Naresh Sharma for giving me the opportunity to come and speak here. And let's enjoy the next 3 days. Thank you.
Thank you, Mr. Muninair, for summing up of those words which were said sometime back on this stage by the legendaries. It was a very difficult task. I can understand that what to choose and what not to choose. And you justified by picking up the summary of it and saying and giving an example of a man for a dog. And yes, in the today's world, the profiles are changing, the roles are changing, the needs are changing. So everything is changing, and the automation is the only solution which we can see in the coming future. And now I request Shri Thiru, the President, Corporate HR, to please come and give your valuable ideas. Sir.
Mr. Suri, Mr. Naveen, and Mr. Muni, my dear friends. I will not take much of the time because we have a very sophisticated and expert available for the next session. I will give you 3 examples from my previous experience. Because why people are selected with experience is that they don't commit the same mistake what they have committed in the previous company. One is why it is automation. Like Mr. Oni said, 10 years back I got an interview call from US, and then that I should go and meet somebody in Bangalore to be a HR manager for an unmanned factory and reporting one line to Singapore, another one to New York, another one to Australia. I was not mentally prepared, and really so. Unmanned factories are going to come, not necessarily in India for the next till I retire at least, but it is going to happen. And like other example also, dog and the man. So only two people, and then for that if they can afford good HR manager, I can be a good HR manager also. So in all this automation, couple of things you should always keep in mind, because the people will come and then sell you all sort of sophisticated products which are not relevant for us today, may be relevant for tomorrow or day after tomorrow. Is my cost of production coming down? And one of the good entrepreneurs used to always say, everybody dies one day, so I should be the last one to die in terms of low cost production globally. So globally, it should be the last one to die, if at all the entire, like somebody said, Kotak film has died, and Kotak should be the last one to die. So we should be the last one to die. So cost focus should always be there. Whatever sophisticated automation you want to do, it should have a relevance, and it should reduce your cost of production. And improve efficiency is always obvious. And as you, another example was that when we are talking about skill upgradation, and in one of the Asia Pacific HR conference, one very intelligent Harvard professor said, why are you upskilling the organization? You have to really de-skill the organization so that your individual dependence and individual discretion is taken away by automation. So are you prepared to de-skill the organization? Yes, it is a thought process. We should de-skill, remove discretion, automate, then consistency in production will automatically come. And quality, earlier days, Suriji, myself, and all that, earlier when we worked in factories, there used to be a quality control inspector, then chaser and all. Nowadays, everything is inbuilt. And today, yes, it is inbuilt, and tomorrow, everything will be integrated. That is what SPS said in his talk about 9 points. Everything will be integrated. And Mehta also made a very good point. Engineers will become doctors. They will not be going and letting the machinery, disturbing the machinery is working peacefully, but you do data analysis at the macro level and micro level and decide what you need to do in future. So quality improvement has to happen. Above all, safety. So we don't have any right to injure somebody who has come inside our factory. So automation should help safety improvement in safety. Not even one area, not even small area. Safety, quality, efficiency, and cost reduction. So if these 4 things are there, then you can go and buy whatever you want in terms of automation. When somebody is selling the product, they will always sell that this is the best, this is the best. Then they will give you discount also. So when I attended one spiritual training in Coimbatore, that Guruji said, what you need only you should buy. What is not needed, even if it is given with a discount, don't buy that. It may be relevant to some other country, some other context. It may be relevant after 5 years, 5 days, 7 days. But what is today? What is my relevance? Will you buy if you are staying in a 1.5 BHK flat in Bombay? If somebody sells you an elephant with 50% discount or 75% discount, will you buy? Earlier I said no, we will not buy. But today with e-commerce, people may be buying also. So that is what is happening. So discount, all these things will happen by the relevant product for today and with the scope to enhance it for near future. And as you go along, you can always move forward and take whatever you want. The second one is this symbol. I like this symbol. Maybe I will congratulate who has put a robotic and then human. Human touch you cannot take away. When I was working for a FMCG company, and there was a soap wrapping unit, and we used to select 10 standard fail paper for packing. Once you take fast paper, you will be thinking. So what you need quality, right paper. 10 fail for packing. And every 30th second, one wrapper will not come into his hand properly, and then it will fall. So from Bombay, industrial engineers came, then they put this kind of a camera, and all these things were happening, and then for about 15-20 days, nothing was, they could not resolve anything. Then I used to take morning rounds to the factory and talk to the packer. What is this happening? Everybody is monitoring from Bombay also. What is happening? Then he said, sir, I know, yes, every 30th second, one wrapper falls off. So we don't know how to solve this problem. So all engineers, everybody has given up. Then I said, why are you not suggesting something? And you don't know the problem. Because he was mischievous and he was smiling at me. I said, you know the problem, you can solve the problem. Let me know what is it. So nobody asked me, so I never told him. Then he said, slowly turn like this. And there was a big industrial fan which was oscillating like this. Every 30th second it will come and one wrapper falls. So ingenuity, creativity, don't think that it is available with engineers and PhDs and so on, or consultants. It is available with this already, which is available with the ordinary worker. Please ask him. Once you ask him, he may come out with a low cost solution. So need not necessarily, all solutions need not be automated, all solutions need not be bought, some solutions can come out and very easy. The material stores and all that, I was very proud when I showed the Yamaguchi when he came for KPM. He showed an excellent store. Everything, code, this code, that code, everything. And he came and then after that he came and then said, why stores? So stores is an ideal money, no? First out. So people are questioning the basic concepts. So automation also, if it is helping you, please go ahead and then do. And then don't forget this. How to integrate this will be the best thing that we can. The other one is safety. Once you say safety, everybody will be paranoid. Once you say as an operating manager, I am engaging DuPont safety, then people will say whatever you do in the name of DuPont, nobody will touch you because DuPont is the best. And in one of our mining company earlier this month, there was a small conveyor which was going on. And then not protected also, need not be, or can be, that can be a debate. It was not there. Then one fellow jumped, instead of walking 50 feet, he jumped and then he fell. So safety, everybody has come to executive committee level, everybody was talking how we can fell, can we put a, it's not a rotating machinery, why I should put a guard, and one can talk about it. Then one gentleman who was coordinating DuPont said, why not we engage robots for this? I mean, somebody is required to do a particular job in a particular manner. That has to be a discipline issue or insisting of standard operating procedure rather than robotics. Robotics can happen in what? Very highly inflammable situation, hazardous situation, temperature, 1,200 degrees. Those areas is okay. Or maybe textile is required in automobile companies. A simple conveyor or a platform to be provided. People are talking about 30 minutes they have been discussing about can we do robots. And when I asked this 5 why, all of you know, why we failed. If you ask the 5th why, the 5th why will not be implementation of non-availability of robots. It is a simple issue. So don't complicate life because everybody is having an issue and production is not there, customer is not there. On the top of it, we also internally when we have when we have to run the production and then give. Please don't complicate life. Life is already complicated outside. I know people from Chennai are coming with this kind of water now. So let us enjoy life. Let us have simple solutions. And I am not against automation. I am again saying automation is required, need of the hour is required, relevant and purpose. We should always go back to the purpose for which that machinery has been bought. Quite often we buy something and then we forget it. And then purpose is lost, then process is good, and we are reviewing process only, but forgetting the purpose. One gentleman very jokingly said, what are you doing? He said, no, you cannot say, no, I'm not doing anything, because he's paid salary at the top. He said, I am reviewing minutes, wasting hours. Or I am busy reviewing minutes, wasting hours. So, relevance is important. Of course, factory level nobody wastes time, but at least keep that in mind. When somebody wants to come and create a confusion and then sell some product, don't buy automatically. Whether it is relevant, whether it is serving the purpose, and whether we have the scope for improvement as we add on. And in one of the SAP SR platform, SAP is implemented. Then on the top of it, another company comes and then tells me that, sir, we can predict actually how many people will leave. Okay, IT companies predict trend analysis. Then he said, I was listening. Then he said, we can exactly predict who will leave and under which manager he will leave. And before that, he told me, sir, we can give you data that that under which manager people are living so that you can control it. And then which manager people are living, I know why I have to pay software. Then you change that and then set cloud or whatever it is. We can really see under which manager people will live. Then I said, even assuming that data is available to me, I will not buy that product. I will not see the data, even if it is coming, popping up my screen because my boss has bought that and it is coming. I will not see because it will color my opinion. Even if that fellow is not going, I will be looking at him and when is he going? Even if he has gone for a temple, I will spend room and that he has attended the interview in Bhubaneswar, isn't it? So let us not color. Let us take life as it is and then move forward. And JKO is an excellent organization. I just joined about 4 or 5 months back. I visited most of the launch factories. 60-year-old factory in Rajasthan, this place, in a remote place. Nobody can imagine company has spent a million 2,000 crores for a fully automated plant. Even Chennai and other airlines also robots like children, like your grandchildren running here and there without creating any problem. So we are in good hands and we need to do relevant things without losing purpose. So that is my humble request. Thank you. Now we can clap.
Thank you, Mr. Kedu.
Thank you.
It was a very nice and critic comment for the theme of this conference. It was very good, and definitely we all need to think that when we are talking about the need of the hour, need of the time, need of the moment, we should also think that whether we are making these changes for the sake of the changes or these are really required. So that is a very, very clear message from his address. And yes, if we see 50 years back, the people used to travel 10 kilometers, 12 kilometers to fetch our bucket of the water. And today, the same water is available and by the sense of your fingers is available in 20 places even within your home. So this is how the new expectations and the facilities change. Years to come, months to come, there's a lot of change to the automation can come. Yes, we should be very, very sensible and finding out the solution so that it helps the real mankind. One of our earlier boss used to say about KRA, as he has just said, increase the manpower productivity, and you will find the word KRA, क्यों रखें आपको? So we should be doing because yes, the all kind of things, this handshaking with the robot, what we are doing is replacing the manpower. No, it is really not. We should understand the sense of it. We are making this frame so that we can fetch those facilities, we can improve those facilities much faster in a much convenient way. So thank you, sir. We will definitely take a lesson from these cautious words. And now I request Shri T. Vidyasagar to take on the further proceedings and introduce our next guest speaker. Shri Vidyasagar, please.
Good evening, everybody. Nice to see all of you here. It's a great privilege for me to introduce today's expert speaker, Sri Dr. V. Rajesh Natarajan. He has all the way came from Chennai, and I feel privileged and proud to give a brief about it. Before that, I request V. Manoharan, General Manager Engineering, JKO Mysore, to present the overbook and okay. Welcome. Dr. V. Rajesh Natarajan is a seasoned business intelligence and data mining professional with more than 15 years experience in data mining and knowledge discovery in database field. He has been associated with this field since the beginning of this activity. Presently, he is working as a principal consultant, big data analysis with Big Data and Analysis Group, Tech Mahindra, Chennai. Dr. Rajesh is an electronics engineer and he has did his PhD from IIM Bangalore. He has rich experience in various fields, both in blend of academic and as well as industry. He started his career with Reliance Industries, Limited, in instrumentation department, polyester fiber yarn plant at Patlanga at the Maharashtra. And his career, Dr. Rajesh has worked with the Business Intelligence and Analysis Division in Wipro India Limited, Hexaware Limited, and Cognizant Technology Solutions. He worked in multiple domains in his career, including banking, financial services, insurance, manufacturing, retail, hospitality, and the pharmaceutical other industries. As academic side, Dr. Rajesh is a full-time position. He was with the as assistant professor IT and systems in IIM Lucknow. And he is also visited various. He is a visiting professor at various Indian top institutions and as well as US and Spain. And in his credit, he has published a number of articles, published more than 20 articles, and he has also participated in AFC's symposium, national and international level. Now I request Dr. Rajesh to give us. Thank you.
Okay. Hello.
Okay. Very good evening to all of you. Thank you, Mr. Vidyasagarji, for so much kind words, and I will try to kind of match your words. So I'm very happy to be here. It's a great privilege and honor for me to be here amongst you. People, I thank the entire JKO organization for inviting me, especially Sriji, Guruji, Mr. Rameji, and others, Mr. Shamaji, and other dignitaries. So it's a great privilege to be here. And now thinking about what am I doing in a JK organization conference. So what is my relation with JK? Right? So looking back at my career, after completing my PhD, I was at IIM Lucknow. And during that time, our chairman of the board of governors was Shri Sai Shankarji Sinha. So somewhere, there is some connection, I would say, which would enable me to talk about this. So I've been working in this area of data mining, knowledge discovery, whose name has changed now to become big data analytics, right? So essentially, it is like evolution of the same kind of analysis on taking this from data. So I will be talking about that, and I have title this talk as leveraging the power of enterprise data because I don't just want to confine it to the manufacturing field, because I think an organization has data coming in from not just manufacturing plants, but also from other areas like the markets, the external data, the marketing department, or right from the suppliers, etc., etc. So the entire enterprise data can be leveraged to add value in organizations. Okay, so let me just I work now as a principal consultant with big data under the group big data analytics with Tech Mahindra Limited at Chennai. So I have structured the talks like this, and basically, if you would like to change it or ask anything else, right? So I will open to any questions at any point of time. If you feel that I'm not like talking sense, please interrupt me, and we can have a discussion. So I'll start with the technology trends. What has happened, and why is big data analytics become a big buzzword now, right? So what is it? And its need. Then looking at the characteristics of this data, what do we call as data? Data always existed in organizations, but sometimes nowadays we are talking about big data in a big way. So what is it that this data processes which data previously did not process? So what is the characteristics? I'll talk about it a little bit. Then talking about the big data analytics, what are the tools, technologies available for us, and what are the techniques, how do we differentiate between them, and what is the kind of insight you get if you apply any one of those techniques. Then I will talk about some of the use cases which we have done as the applications of big data analytics, and which I have been associated with, and you can take that back and think about this, how a similar thing would you do in your situation? How would you do? How do you talk? How do you apply? What kind of data are you getting? And can you apply some of these techniques which we will be discussing later? And finally, suppose you want to start a small project. So what would it entail? What is the sample project plan? What are the kind of timelines you would need? And what are the kind of skills you would need? Right? So those are the things which I will get better. So let us talk about technology trends and their impact. So what has happened? So what has happened is basically there has been a convergence of three main technologies. That is processing technology, the data storage technology, and the communication technology. Right? And this has impacted data processing in a huge way because now what you can do is you can access data in different ways, in different forms, as the process is taking place. As you're doing day-to-day activities, the data is being collected. And as you collect the data, it has inside itself a lot of insights, a lot of data about the behavior of your suppliers, your customers, and the processes which you are actually implementing. And all that knowledge, which is not explicit, which is implicit in that, is being captured in some form. So what you have to do is kind of analyze it further so as to get core knowledge about that. Secondly, look at data storage. That has also, that the cost has come down. The next few slides show how the cost has come down. It's also good. And data access and retrievals. We have new data models. You had previously the world was working on relational database model. Now it has moved to you have data warehousing, and you have new models coming in. Known as not only SQL kind of model, map reduce, which is a new thing, which we talk about Hadoop and talk about that later. So there's a lot of business impact. So new business models are being built, and new business models in terms of how you can actually access your market in a different way using the data which you have. Increase productivity, innovation in both services and products. Someone touched upon the innovation part of it. I think Mr. Mehta talked about innovation, and that is what this entire data is doing. So how was the data storage done? I hope this is you can see this. Otherwise, I can also take the slides so we can look at it later. But basically, what we are saying is that from 1986 to 2000, there was a slight growth in the data storage, but after that it has exponentially increased. Now we are at 300 exabytes of data, and each 2 years, data being generated is equivalent to the data produced till then. Right? If you look at the history of data production, how much data has been produced in 2015 and 2014, the data produced and consumed is equivalent to the data produced in all the history until 2015. That is the kind of data we are talking about. Then the second is the computational capacity. So data just production is not sufficient. You also have the ability to compute, use the data, and come up with how can you use the data. because a lot of data is produced, if it's all junk, then it's of no use. So the computation capability is also increased, this price exponentially, and also the telecom. So if you look at this, from 1986 to 2007, the storage capacity yearly there has been a compounded annual increase of 23%. 23%. For the broadcast, 6%, whereas telecom, 28%. So each year, the productivity has increased by 28%. Here, general purpose computation, it is 58%, following the Moore's law. And for application, so here we are talking about in millions of instructions per second. The cell phone today, which I have, has more computation power than what the first computers which I used. I mean, 10 times or 1,000 times the computation power of what the first computers which I used way back in 1995. So it is much more powerful than that. We are now talking about 4 GB of RAM for ordinary desktops. That time it was in KBs. Right? So all this has given rise to, and if you look at how data is generated. So one day on the internet, what happens? Right? You have new websites being created, 1,39,000. Now you have so many billions of emails being sent, but unfortunately 68.8% is spam. So this is another a problem which you get when you can easily create data. The cost of the additional cost of sending an email is not so high. So that this is the business component, is a personal component. For search, you see Google has so much searches taking place each day, more than 3 billion. Blogs, about 2.73 billion blog posts are published daily, tweets, and so on and so forth. So this is the kind of data we're talking about on a global scale. And even on the fact an individual organization scale, even if it is a fraction of this, that is also very big. Now, if you look at the manufacturing environment, so we traditionally talk about the main thing in the manufacturing process. But today you cannot just talk about manufacturing process and say that okay, our manufacturing process is the best, because what you produce has to go to your customers at the right time. If you look at the way the internet has enabled e-shopping and other kinds of activities, so you also have to look at what is the kind of distribution chain you have. Should you have just distribution like you own the distribution chain, or whether you kind of lease the distribution chain and others take part of it, other organizations take part of it. Who are your customers? What are the needs? What are the other things which they need? And who are the suppliers? Because suppliers also impact the manufacturing process to a large extent. The manufacturing process, the main plants have to be efficient. That is no doubt about it. They have to produce at a rate, but the rate will not be determined from the other side, that is the customers, and that has to be enabled by your suppliers too. If you look at the kind of data which we are getting, it's like amazing that we are having different kinds of data. This is what I have been talking about data. We call about characteristics of this of big data. We have RFID, barcode scanners, and electronic data interchange, GPS data, then data for the manufacturing systems, ERP, material resources planning, and so on and so forth. Then manufacturing line sensors, which is basically taking the data from the machines, machine level data, transportation systems, and so on and so forth. So the data which are gathering is almost like terabytes of data, and basically the manufacturing plant has the control systems, the supervisory control and activity data acquisition systems, delivery systems, etc., which also at a per second level gathers a lot of data. So if we take this to the next level, what we are saying is the evolution of manufacturing plant as a center of data, because if you look at the comparison between a manufacturing plant and data center being a big data center which has a lot of servers, like Amazon has data centers, different data IT companies have data centers. So what you're saying is like, if you're scanning at a rate of 1 second and you have 5 million points of producing data, a typical manufacturing plant, it would be like the tags, the sensors, the various pressure, etc., coming from the machines, and so on and so forth. And at a scan rate of 1 second, for one 1 per second, and each giving you 4 bytes, this produces about 160 MB data per second. So that is the kind of data. So in one day, you will be producing more terabytes of data. But what are you doing with one string? That's a question which should be asked. So if you're not using it in a way which will enhance the productivity or help you to innovate in a different way, then all that kind of knowledge is going to waste. Okay, and if you look at the number of ports, this is 10,000 ports because obviously the area is more and it needs a lot of machines are there, more than what a data center is. And 5 megawatts of power, this is about 4. And this is only for the communication and the processing. It does not talk about the motors and other things which you need for actually doing the actual manufacturing. That's why the power is kind of less. Right? But still, this is the scale of a data center. Now, if you're going to produce the whole thing, and then if you're going to send it somewhere else, the data center kind of process it and then send back to get the insights, then obviously the time taken is huge, it is large, and you might be losing a lot of opportunities of fixing problems, of doing other things, which you could have done with the same capability were present nearby. So that's why what we are looking at is data center technologies which are already there, like virtualization. So the labs can use those technologies and do things like automatically configure the assets, the machines, servers, etc., according to the situation in which they are present. Right? So a particular robot which is moving to one shop floor will do one set of operations. It moves to another shop floor, it does another set of operations. So all you have is a general purpose robots which are going through different and wherever there is a more need to send those robots there, automatically they get configured and do the particular operations. Okay, so now I come to why big data analytics. So I already talked about how there's a convergence of technologies. So a lot of technologies coming together at the right time, right? So there was when we had talked about the Internet of Things, cyber physical systems, robotics, etc. And these trends, the supply chains being complex, right? So if you look at various companies, they don't have single supply chain. Depending on the product, the supply chain will differ. Some products which are innovative, which are actually new, need a different supply chain. They might be accessed by young people who would be looking at, who will be ordering through the internet. Whereas some other products, the company has a lot of products. For example, your paper itself, JKO. So there might be one segment of your company, segment of your customers, who would be looking at buying those products like schools, and they need a lot of innovation. You have to design, at least keep on designing different notebooks, different colors, different this for those segments. The other segments are more mature. They need a standard kind of stationery day in and day out. So for them, you will have a different supply chain. How you are fulfilling their orders will be different. Whereas for standard companies, for standard suppliers, or standard consumers, you might be using a different traditional supply chain. So that increases your complexity of execution. So the other thing is basically the variety of content has increased. So we talk about structured and unstructured content, external and internal content, like external data, internal data, then data produced by machines, then the social media, then you have the trends, you have the kind of opinions coming in, and so on and so forth. Then the process data, right? So in many cases, the speed of response has become very important. So if you even in a plant, if you know that a problem is taking place somewhere down the line, you would actually shut down the plant somewhere else, or change some other processes or parameters if you can make a different one, supply to a different line. Okay, so now our previous speakers talked about sources of competitive advantage. So basically, competitive advantage is things which you can do which your competitor cannot imitate. And if they cannot imitate, that means you have the upper hand. So traditionally, there were two, and if you look at economics literature, there are two major sources of competitive advantage. Because advantage of scale, which is the bigger the as the production increases, the cost of producing production of one unit increases up to a certain level, after which it kind of another again other kind of complexities come into this, coordination costs, etc. etc. So you have this competitive of scale and scope. Scope is basically dealing with different kinds of varieties which you can produce in a better fashion than the competitors. But today that has been extinguished. You don't have that those competitive advantages. Why? Because everybody can imitate very easily. Some 15 years back, ERP system was something which was unique, which was if you had ERP, that means you are very efficient kind of producer. But today everybody has an ERP system. So IT by itself will not give you a competitive advantage. It is the innovativeness which you are doing that will give you a competitive advantage. So now we are shifted to the next level, where you say that okay, you don't have these two sources of competitive advantage. So what is remaining? What is remaining is the data which you are generating. Are you able to leverage on this data or into the next level and produce new kinds of products, deliver new services, and that will not only improve your process, improve your products, but also fulfill the customer needs. Are you able to think about innovative products which the customer has not even thought about, doesn't even know that he needs? And once you bring that out, that then the customer buys it. So Mr. Netaji talked about this, part that Kodak films, right, has gone out. Similarly, you can see Sony. Sony was the first company which came out with the concept of Walkman. When they had that, Walkman which they had. But now that Sony is in that field, it's slower because now we have big three players. Apple has come in. Every year is bringing up new products, new innovations. So similarly, you could find things retailers like Amazon, Walmart, Tesco are doing wonders with that data which they already have. They actually can tell you. They can kind of personalize your purchases to such an extent. As somebody mentioned, when you kind of when you can click, you do some search. You not be on Walmart site, but some other site also. That information gets, there is a cookie in your machine, that information gets recorded. And they, using recommender systems, they are able to recommend what the other person actually purchased. And they will be recommending those products. So that is the kind of, that is how they are leveraging the data and using it as a source of computing. Okay, so now I'll come to what makes this new data big. Okay. So these are the four big V's. There are many V's. Right? We call the V's of big data. The first is volume. Obviously, this is volume is something which we, because the word big also by it indicates that the volume should be huge. So we are not talking about data which can be which you are used to traditionally. So here we are talking about data at the terabyte level at each day, or the petabyte level, which is much more. Traditional technologies can't handle this kind of a large data. So traditional relational database management systems and data warehouses, which have a star schema and other kinds of schemas, they cannot really handle this and connect everything together. So you have a different kind of technology coming in. So that is what we are talking about, the volume. In variety part of the big data, what we talk about is the formats, different formats. Traditionally, you have data which are mostly numerical data, which you can work with, which you can add, subtract, do the basic arithmetic operations, and so on and so forth. Now today you have different new formats. You have a lot of about 90% of data which organization generates is actually in the form of documents. Your entire knowledge is encapsulated and stored in form of documents. It's not available easily to be retrieved. Then emails. So you can't go through all the emails. So if you look at a typical person, he might be getting about 25 to 50 emails per day, right? And over a period of time, he has so much emails, thousands of emails. Think about whether you could actually, scan all those manually and come up with some trends from the emails. Like so, for example, take a contact center, for example, and it has the job of processing the complaints from the customer. Now it gets thousands of emails per minute because the customers are always complaining. How would they actually, come up with some statistics like these are the most common complaints that we get. So we have to increase some manpower for solving these complaints. These are other complaints which we get. So these are the type of skills which we require for managing these complaints. So all the things cannot be done, manually. So that is another reason why you need, big data. Again, you have formats like, text messages, social media text messages, then images, video. A video has more data than a 10-minute video has more data than the amount of text you generate in a year. Right? So such kind of variety you have. Now the second kind of variety if you're talking about is source of data. What is the source? So traditionally your source will be internal. So all data comes from the internal process, internal stream. But today, just sticking to internal data is not sufficient. You also need to look at external data. Now, 2 days back, actually, the external data in terms of social media data, external data in terms of economic data, so that we can forecast, what is the kind of demand your plant or your product will be having in the future. So 2 days back, I saw that news article which was talking about Walmart, and they fired the person who was actually working on an hourly basis, earning about $9 because he collected all the cans, the Coca-Cola cans and other drink cans from outside when the customers left them, and then took it back to the Walmart and demonstrated that and get some money for it. Right? So it's like then you are scanning that and giving back the cans, and that was apparently not in the policy of Walmart, so they fired this person. So this person has gone to some lawyer or some organization has picked up his case. And that has generated so much emails, and then there has been a lot of Twitter blogs, a lot of other adverse comments about Walmart. And you are just another 1 week will have a big shopping season coming up. So they are really, afraid that this incident, which has spread out, is going to impact the sales in the next. So they're trying to limit the damage created. So organization also has a different kind of challenge. And this unstructured data is growing faster than structured data. So that is, it's doubling every 3 months. So that's another point which we need to look at. The third is velocity. So this is about how fast the data comes in, like how fast you have to respond to the data, and whether you are getting consistent and complete information when it is coming inside. So there are two things here. There is what is the timeliness and the latency. So you get the data coming from the field. You have to process it and act on it, and then do the analysis and act on it. Is there the sufficient time for you to act on it before the data changes? Let me give you an example. So in the hospitality industry, we are checking in. Suppose if a hotel has various offers. So the time of checking in, they are about 15 minutes, 20 minutes. They have the window of opportunity to make different offers for the various products which they have in the hotel. If they miss that opportunity, 15 minutes or 20 minutes to make your offers, then they have lost the opportunity. Similarly, if you look at airline seats and so on and so forth, so that is so for the airline they have a price point. What price should they sell last hour tickets? So if it is too high, then people will not buy. If it is too low, if it is too low, then you have missed that amount of profit. So then the important question which they have to answer is what price they should set for last hour seat, 2 hours before that, and so on. So the timeliness and the relevance. So that will have this issue of when are you getting the data, how fast can you process it, and when should the action be taken on? Whether you can do that. In the case of Amazon and other online systems, it is in terms of seconds. You have to have a real time turnaround in terms of seconds, and that is sometimes possible, sometimes not possible. So they miss the opportunity. The fourth V is the veracity. It is the reliability of data, whether it contains noise or bias, or from where are we getting the data? Is it mostly reliable, or is it like not reliable and not reliable? And so you have to treat it as junk. So that is another important thing which you have to look at. So these are the four things, things which make a data big. The other V's are, which various authors have talked about in various forums, talk about the variability, the visualization, because we're talking about very many data in a very huge scale, and you're not, how would you actually interpret the results of analysis? So you need a very good visualization techniques to help you to do that kind of interpretation. Then other things are validity, the volatility, which are actually a subset of that. Then what's the value which your data brings in? Then you have viscosity, which is similar to this latency, and variability, which is basically the rate at which data spreads. So the rate at which the data and rumor spreads is a very important factor for Walmart now, right? So that is so these are the other big V's which various authors are talking about, but essentially, if you look at literature, they only talk about these four, and especially the first three. Okay. So any questions? Okay, so now I talk about where we are in the data, big data science. Big data in the Gartner's hype cycle. So you are aware of hype cycle for emerging technologies. So what happens is that whenever a new technology comes in, you have an innovation trigger, which basically means that people are very excited about this, and that results in a peak of infinite expectation. The expectation from that particular technology, like automation, goes up and up and up. You're expecting more and more. The expectation is that. Then it once it reaches its peak, then there is a disillusionment because many wrong expectations have been made. Right? So all those expectations will not be fulfilled, and so the technology comes down, and then they see that okay, our expectations are wrong. Only we can expect only these things. So then they start using technology in a proper manner. Then we have scope and entitlement and the backup productivity. So after the period of time, it kind of matters. So last year, big data was somewhere here. Basically, it is going to the rough of distribution, and the many of the hype which was surrounding big data. Some of the hype was not being justified. Some of the things we are talking about, big data was not being justified. But then we have other things like data science, analytics, etc., which have just started off, coming up. These things are not new actually. So because I mean, statistics has been there for hundreds of years, right? So this is only statistics. We are looking at statistics from a bigger scale, large scale. Right? So we have AI, machine learning, past 50, 60 years. So all those are coming together, and consultants and other people are calling them different names. So they call this operations research and things like that as descriptive analytics. So operations research has also been there for quite some time, and we have data science and so on. So in 2014, the data was somewhere here. In 2015, it is not there because they say that it has already, it has come to the scope of environment, and a lot of companies have already adopted data analytics. So now the main thing is now machine learning has become a big thing, and advanced analytics is self-sufficient. So a lot of terms, but all of them are more or less similar. So any questions here? Okay. So either I'm doing a very good job or I'm doing a very, very bad job.
Let me ask you a stupid question. The fall, any change management process also, everybody goes through this cycle. But in this big data, the fall seems to be very, very high.
Yeah, in 1 year, it has actually gone out of this because it is no longer as an emerging technology. That's what they're saying. It's already emerged and it has now become a standard technology. So in emerging technology, you will not find ERPs or something which has been there for quite some time. So what they say that they have realized the value, and many companies have realized the value. So they are removing it from the emerging. Okay, so now I will come to a little bit on the tools the technology and what is the techniques being used. Some of them will be a little bit technical. Okay. So now we have been talking about Hadoop, right? So we have all heard about what is Hadoop. So Hadoop basically. So how many of you are aware of Hadoop? You must have heard of it. Right? So but not known what it actually does. Right? What is this Hadoop framework? Why is it so much of? So you consider a computer which has a central processing unit, a data storage, and central processing unit has two things: arithmetic logic unit and another, memory. So what you do is basically you will take the instructions from your data storage, put it in the main memory, and then the central processing unit will look at each instruction per time and so on. So what is happening is the data is getting transferred from your hard physical storage to the memory. Okay. So that takes a lot of time. That itself consumes a lot of time because your physical storage has a particular speed. It cannot move more than that speed, right? So there is something like that. So if we have a very big, even if we increase the number of processors to a large amount, if you have say 100 processors, but if your data is very big, still you have to move those data to the main units, main memory, and that will consume a lot of time. And beyond a particular point, you won't get the efficiencies. So what this framework tries to do is it tries to send the programs to those data where data is located. So instead of data moving, the program being smaller, the logic being smaller, is being sent to those data. So places where the data is there, data is split into those various units, and the program is being sent to each one of those units. It does the partial computation, and then the results are then being merged together, and then we get it. So that is why it is basically able to work on very large data. So it's basically it's an open source software. So any of you can actually download Hadoop from Apache and then install it in your computer. So it is used for distributed storage and distributed processing of very large data sets on computer clusters on commodity hardware. This you don't need a supercomputer to do this kind of processing. So your ordinary computers, if you have 10, 15 computers together in a Hadoop cluster, you can very well serve as you can have processing power of supercomputers. That is what.
But generally, when you work on that, normally it comes to a RAM. You work on the RAM.
So you are giving to the RAM, and then the processor will read from the RAM. So bringing to the RAM itself takes a lot of time, and it takes, and you need a processor for bringing it to the RAM. Okay, so that is the processing also. What is the time taken to bring it, and the processor has to bring it. So it has to do two jobs. Bringing it from the RAM, taking and you cannot fit the entire data set into the main memory. Only a part of it can be done. So you can process only part of it. So processing also the kind of programs you can write becomes much more complex. You have those model also, but it has to do much. It becomes much more complex. But for business applications, you don't need such complex computations. So this kind of framework works much better. Okay, so what is the core storage? So it contains two parts. What is it? It's a fault tolerant. So what it means is that you will be having thousands of machines, and you can remove any machine. Other machines will take the job dynamically, so it will not crash. So that basic philosophy is that behind this entire design. So in fact, in Google, how they test the data center is working on. One of the top people go and they just remove those, from the racks, those processors, and it should not fail. If it fails, then they have a problem, and they get all of the quality. It should automatically take over. That kind of fault-tolerant system we are talking. So here we consist of two basic parts: the Hadoop distributed file storage system (HDFS) and this processing part called as MapReduce. So MapReduce was a basic algorithm which was actually fueled by that. This came out from Google. MapReduce. So they were the ones who came up with it, and then it has become open source. So now what it does is basically what I talked about, and I will not go through this again. But what I'll do is I'll show you the basic structure of the ecosystem. So these are the three main parts of the three main programs which control the entire Hadoop ecosystem: the distributed storage, which is called HDFS, MapReduce, and YARN. So this is for distributed processing, and this is for distributed scheduling. These three main parts. Now, once you have this, then they have built other kind of functionalities like integrating other programs. So you have something called speak and write, which is basically used for querying of data access, querying of this HDFS. So how do you query? Instead of relational database, this is a different kind of distributed storage. So you have speak and write, and the data storage is basically HBase, Cassandra, and so on and so forth. And for interaction, visualization, execution, development, we have another set of programs coming in, data serialization, then data intelligence, Moho. All of them are setting on the Java virtual machine because it has been built on Java, and then the operating system might be any one of this. Now the other thing, so the data is Linux. Again, Linux is all also Linux, and Linux, and then we have Windows. Now, other thing is data integration, and this is very important because you have various other systems which are in the ecosystem, not just the Hadoop. You have Linux databases, we have your SAP system, we have other proprietary databases which are already created. Every different functions will have different kinds of databases. They will have Excel files, they will have text files, and so on and so forth. So all that needs some kind of integrator, and that is basically these three programs. A school and support. And again, so for management, monitoring, and the jobs are to be sent and so on and so forth, you have this kind of thing. So this Hadoop is one such technology which has revolutionized the big data. Another technology is basically Spark. This also is an open source which was started in the AMP lab at the University of California, Berkeley. But afterwards, it has been related to Apache Software Foundation, and it has become one of this is the latest thing. And what it does is it leverages much more than what Hadoop does. So it has connectivity to Hadoop too. But in addition to Hadoop's paradigm, it also uses something called as multi-state in-memory primitives. And this is actually helping to increase the performance up to 100 times. So it kind of does a lot of calculations which are 100 times faster. MapReduce can do basic things very fast, but for more complex things, you need something like Spark. So this is very suitable for machine learning algorithms. So things like recommender systems, they use Spark because you have to when the person is coming in and then just querying whatever, pick a query, it has to go to the backend, search the database, find out which segment this customer belongs to, and from that pick up the recommendations and bring it back. So that requires something much more than that, and that is why you need something like Spark. So Spark, I hope this is clear, but this was the best quality to get. So it has different data sources. It could be a Hadoop, it could be HBase, or it could also be your Oracle database and so on. You have a Spark code which basically interfaces with the data source on one side and interfaces with other programs on the other side. So there is the Spark SQL which is used for querying this database sources. Then streaming. Emulate is the machine learning library which can be in either Scala, Java, Python, or R, right? And then you have graphics for actually depicting the entire thing, the results not visually available. So this is basically the Spark components. So these are the two technologies which are actually kind of changing the way the data is being used today. Okay. So I would, if you have, this is also open source, you can actually download it, install on your machines, and kind of experiment with it, how it kind of works. Put your data from your own lab and see how you can do different kinds of algorithms. Any questions? Yes.
Okay, so can these technologies be hooked up with our existing ERP system? Because we have a lot of data here.
Yes, they have many plugins, right? It can be from that and pulling the data.
And pulling and put it back also.
Yes, we can do that.
Whatever the result
Yeah, yes. You can
then,
put it,
then we can get the customized report of the
that we can do. On the other hand, you also have the graphical visualization packages integrated with this project, so you can actually see it here also. You have
Yeah. In case of Hadoop, what is the limitation? Is it applicable for small data? And also, what about
small data you would not lose it.
what about its security and stability?
So you have this different kinds of other programs sitting on top of it, right? So these take care of various aspects of this. So the security we have found security and stability is not a concern because once you have defined how much data you are going to receive and you define how much it will increase, so you can automatically design your entire Hadoop system based on that. You are taking that kind of approach. That is, you know what is the volume of data to mean, what is the processing speed you need, and what is the kind of results for the latency which the person who is actually looking at expects. So based on that, you would increase the cores. I talk about this, right? The clusters, nodes in the clusters. So you would increase the nodes in the clusters. Once you increase the nodes in the clusters, it can have a higher processing. And it is very stable because if one cluster or one node fails, automatically another one takes it. The job is ultimately sent to another. So there are also different configurations. You can have clusters in one location, or you can have clusters in multiple locations. So in our company, we work from Chennai, but we have some clusters, some nodes in Hyderabad, and we routinely transfer data from there. And we have built a platform which is actually you can search on the web, but on the back end it uses Hadoop. So there is a couple of servers in Hyderabad which is actually serving it, and the programs are running in Chennai. Any other questions? Okay, so now we have got the data. So how could you actually get insights from this data? So you have big data, got the data. The next step is how do you process data to get insights, and that is where you have the entire field of data mining and discovery. And that is starting from the business model definition, the analytical task definition, the analytical techniques, algorithm reflection, model validation, and result interpretation, the entire thing. And then that once you interpret the results, it might result in another business problem or another task. So I will talk about this in a little bit detail. Let me go to this slide. So suppose we are having a very unstructured situation where you don't know what you want. You have all this data. I have terabytes of data, but I don't know what to do. How could I leverage the data? So for that, one way of looking at it is do some kind of data discovery process. So what you do is basically first understand the domain. So here the domain is very important because the data scientist can talk about the algorithms, etc., but he or she will not know the domain. They will not know what actually takes place in a paper plant, what actually takes place in tire plant, or how the customers are, who are the customers, what the segments, different segments. They will not know. So for that, you definitely need a domain understanding. First, look at the domain. Look at the business problems which are facing. Identify the opportunities. Next step is what is the data you are collecting? What are the different data sources? What are the relevant variables which you have? All variables, all data may not be relevant, but some of the data will be relevant. So suppose if you looking at a CRM system, you actually take a form and ask them to fill in the form. So out of that, all the data will not be used. Some of them will be used. So what are those relevant variables? And you need to create new variables based on those variables, depending on your need. Then the next step is exploratory data analysis. There is this preliminary data analysis to understand what is the data saying, where is it coming from, what is it saying, what is the various values which are So you have machine plan, and sensor is giving you data. Say it's a temperature. You should know what is the normal range of temperatures. What's normal range? What's the abnormal range? What will happen at different? That domain person will be able to say, right? But when I'm exploring data, I should know the benchmarks. What is it? So that I could get from the exploratory data analysis. I would say that okay, this is the average temperature, which has made it, but there are outliers. This is the highest temperature, this is the lowest temperature. See, go back to the domain and see if this is normal or this is showing some situation which needs an alarm to be raised. And based on that, you can base on it. Then there's a hypothesis testing, and you have a lot of hypotheses. You know the process works like this. We have something in the back of your mind, and you want to say if the data also tells you the same story. So that is the next step which you look at. And finally, analytical goal setting, which actually changes, which gives you the actual goal which you want to do. And then you go for the modeling process. I will not talk about this in detail. I will share the slides. You can have a look at it. Right? So what I want to say here is only one point. If you look at, there are two aspects of this. One is the business knowledge, which is needed in all the stages, right? From data collection, data preparation, model development. It's not just about statistics. It's not just about AI or machine learning. It's about also about business. So that one thing you should be in mind. Secondly, main problem is not the algorithms or the model. Those are the easiest part of it because you already have this developed. You have the packages that are ready. What is the main problem is how do you the data collection of data, and getting data from various sources and bringing them together in a format which is algorithmic. That is the main problem. And that takes about 60%, 70% of the time. The rest of the effort goes in basically, developing the model and then publishing the results. Okay, so this is the analytical task in algorithms, which is basically where the main knowledge and discovery takes place. So I have actually categorized this into various main tasks and algorithms. So I have worked. So if you look at this is a very broad, very big field. My PhD was in this. Only one aspect of this. The small aspect of it. Okay. So that is how big the field is. So each method, the people have been working in customer analysis for 70, 80 years. Okay, and each thing you can have a full subject devoted to it. In fact, different universities have different subjects depending on the graduate level, depending on the expertise of the person who is teaching. Okay, so these are the different algorithms. So what does algorithms do? So first is this regression. So regression tries to find out the trend, what's the trend happening, and tries to fit something like a straight line or a multi-dimensional line. And then using that, if a new data comes in, then perhaps it should fit in some of this line, so you can use the point line as a proxy for new data and say that okay, great, that this is what value is going to be. Right? So if you have say some 10 variables which are explaining your sales. 10 variables. Say it is like number of customers, and what is the number of what is the number of orders, so on and so forth, unfulfilled orders, and so on and so forth. So from that, you can actually pick that values and then which will give you a relation, telling you what is the rate of sales. That is basically looking at regression. Now here we can classify it as supervised and unsupervised. In classification, what we do is basically group that various data points into different clusters. So we have you can classify your customers in different ways. One by the use they make of your products, whether they are using it for school, whether they are using it for something else, and so on and so forth. So that kind of classification is done. Then you have anomaly detection, which actually detects whether a particular pattern that you're seeing is an anomaly or is basically a normal process. Genetic algorithms which uses how the genes operate, like evolutionary way they operate, survival of the fittest. So you here what you do is you create multiple models, and then allow the models to fight with each other using data. And the best model emerges out as the solution. Then you have link analysis, which is basically what you do in Google search. Like you have a page and algorithm. It's trying to link all web pages together. So that when you type in your keyword, the relevant web pages comes. So link analysis, neural networks, which is basically looking at the entire paradigm, looking at how you are predicting using how your brain works. So here you have different concepts which are borrowed from biology and your neuroscience, basically hidden nodes and so on and so forth, and two basic algorithms. So here I looked at algorithms. This is basically the analytical task, and these are different algorithms. So the thing is, if you have business problem, you can use multiple tasks to solve it. So for a prediction problem, we can use regression, we can use networks, we can use genetic algorithms, like multiple problems. Which is the best? For that, we need to do some kind of model fitting and generate a new models. Okay. So this is the basically again, if you look at it, one task can be solved by regular algorithms. So you have 3-4 algorithms for time series analysis, and an algorithm can be used for multiple tasks. Okay, so same regression can also be used for something like normal regression, wherein you change the whole goal. Okay, now I come to the actual ecosystem. Basically, how the big data analytics can look like. If you look at it in terms of different components, different technologies coming together and working. So these are multiple components, but you may not have the entire thing for actually working on it. So on this side, you have structured and unstructured data. Structured data can be from the company, from machine, macroeconomic data, etc. Unstructured can be from the market, web crawling. You can do web crawling to find out your competitors. What are the competitors doing? Go to visit the web pages, look at the products, use a web crawler to do that, and then instead of manually doing it. Because web page new products can come in, very frequently, and you cannot keep on visiting. You cannot have one person sitting and doing that job. So use web crawlers to do that, right? So that is extracted. This is in the Hadoop system. This is the traditional database. Traditional. There is traditional enterprise data warehouse, which has a data staging layer, which has data transformation, then you have operational data source. Then you convert that into a hybrid data store, bring in stuff from unstructured and structured database, and then select only a portion of it for the analytics. And that is done by using different analytical tools and techniques like R or something else. So what are the tools which are actually available? So we have typically so many vendors out there and so many tools and techniques. These are a sample of tools and techniques. Does not cover everything. So if you look at these are data coming. The extractors. You have Splunk, which is basically very good for streaming data, real-time data, which comes in machine logs. So it indexes it very fast. So you can it's very good for real-time streaming, informatica and other cognos and other things. Cool. Then this side is real-time streaming. This is the DFS part of it. Hadoop, these are the different Hortonworks, Cloudera, etc. They implement one Hadoop. They have added something to Hadoop and they are implementing it. So these are the various Hadoop implementations. Here you have the analytics engine. You have SAS, which is predominantly the most important used in business. But it is not open source, it's very, very expensive. So now we have an open source called R, which actually is taking up business with SAS. Because this is open source free, you can download it, and in about 15 minutes you can start working on it. It's so easy. So that is one thing. And then on the visualization front, we have things like Tableau and so on. This is the typical ecosystem which you can. Any questions so far? So how much time I have?
10 minutes.
10 minutes? So I'll directly go to the applications. Okay. So I'll skip moment. I'll skip this because you might know me doing this. I'll skip this also. I'll go to some of the case studies which we did, based on real time what we have our experience, my experience on this, and maybe you can relate with this, and maybe I'll talk about this for 10 minutes because this is this comes from the aviation industry customer, and this is very typical of how much data they gather, but they are not actually using it. This is we are doing it for a very for an aviation customer, specifically Textron, which has Cessna aircraft. Like you have heard of Cessna, it has small aircraft, medium size aircraft. The big players are Airbus and Boeing. We work with Airbus, but this was not for Airbus from Cessna. So this is one of the leading manufacturers. So each flight which takes place, each flight, 1 hour of flight, they have 1,800 or more than sensors inside the vehicle. Sensors for temperature, sensors for pressure. How does the aircraft sense that it is on land? Or does it sense on the lab? So using pressure and so on, altitude and so on. So they are about 1,800. They have more than the sensors. And each sensor, they don't have single sensor. They have multiple sensors because they need to be redundant. Otherwise, if one sensor fails, then you will have some problem. So they will have multiple same data coming from multiple sensors. Okay. So the 1 hour of flight generates about 1 to 2 terabytes of data. I mean, it should be not per day per flight. And that is in a machine form. So what they have, there is PCBs, circuit boards, which connect to different systems. So you have that the system which controls the wing, system which controls the wing flaps. You have seen that when aircraft taking up and landing, which is the wings, they change the position. Right? There will be the flaps, and landing will come up vertically. So that it provides some resistance, and the braking is much more even. And if you look at it, they will close it once it takes off. And then before landing, they will open it. So they have so many data. A lot of data is being generated, about 1 to 2 TB per flight, but they are not using it. They're generating it, and only for extreme cases they use it. They use it only for maintenance, monitoring purposes, see if it is okay or not, and then they will use it. The other thing which they have is a maintenance data. Periodically, they will, whenever there is a big problem, and that gets reported multiple times, say the same. So they have redundant 2 sensors coming and giving you data. One sensor is constantly failing. So if it is failing for say 5-6 times, then they take it to the hanger, they remove the part, and then they check the part if it is okay or not, and replace it or do some other kind of maintenance activities. So that data is recorded in the maintenance database. Now this data and flight data is not connected at all. So there is no connection between that. And here in the maintenance database, the person who works on this, technician who works on it makes notes, but they don't feed it inside the computer. So there's no way I can know what is the kind of fault which has happened, which caused this particular piece to be removed. So that is not there. So what we did is basically we want to kind of merge these two and look at how we can identify any patterns from that particular data which we are getting. So basically the thing is they have how do you connect these two databases. Now the connection between 2 databases, we had to go back to the domain experts and talk for about 5-6 hours before we look at the product, the SKU, product identifier, which was used. Because here what we are looking at in the flight database is not the end sensor. What we are looking at is the PCB which is giving the. And here what we are knowing is the end sensor. To connect the two, you need to go to 3-4 stages. So you need to find out which is the sensor, to which PCB it is connecting, to which and how do you which SKU or which the product ID, and using that to connect the two. And from that, then what we did is we looked at when was that thing removed, right? When was that particular part removed, and then looked at what is the nearest day when we took up flight. So today, say it is 25th, I have removed the part in my hangar today, but it has the flight, the latest flight was on 20th. 5 days was sitting in the hangar window. So I cannot use the data for 5 days, right? Because there's no data actually. So I have to start using data from 20th and to go back behind it. So we went for 1 month behind that, from 20th of November to 20th of October, we looked at all the data from the maintenance from the flight database and to find out whether there's any pattern emerging from all the data is, how the data was. So we looked at it and we saw that we can classify those days as two data points. One is just before the failure, for 10 days it is showing some abnormal data, and then they remove it. So this is not consistent across all the aircraft. So we have to do some statistical analysis to see if this significant, the pattern is significant or not. And using that, we would be able to kind of come up with two approaches. One is logistic regression model and distribution tree model to predict what is the propensity of power pattern methods. So given that you are getting some input data today, you feed that into this decision tree or logistic regression model to tell you whether this data represents 5 days before removal or 4 days before removal or 10 days before removal. So that is the kind of work which we are doing, kind of trying to do. And this is just very small. And this is something which you can extend to your machines also. So I was talking to one of your colleagues, and they were talking about data coming from the machine data from the machines and data which is there in the ERP systems. So how do you merge that together? Something similar to that, if you can think about, you can merge them together and come up with an interesting use case. I have some time for this is all the time I have. Time? Okay. So I will just stop here. I will share this next so that we can act on. The other things are I have been looking at demand forecasting for another company. So how do you forecast the demands? And that we have used something like this is entire process selection of modeling technique and so forth. And this is a graph and series graph we got, and this is a prediction which you did. And these red things are saying that when the risk of conditions. And the other thing is part classification. So you are classifying parts not just based on the cost, but also how much they are replaced. Whether they are being medium cost or medium moderate and replaced and so on. And this is a sample project plan. It's quite simple. So I'll end this with just some implications for organizations. What are implications? So these are some of the implications to that. So data should be looked at as an asset. It's not something that is and it is an asset which can give you multiple rewards and become a kind of a source of competitive advantage. So what is
collected data? There will be a lot of duplication.
Yes, there are
eliminate that duplication.
Yeah, duplication methods can do that. Elimination of duplications. In fact, there is stream like master data management. It tries to use a single kind of identification for the different components which are spread out within a particular organization. So a particular, you might be identifying a particular stream by one kind of identification code. In another company in the same organization, they might be identifying it by different codes. Now, how do you kind of deduplicate it? So there are different methods for it. That looks at the confluence for customers, like when the two companies are merging, two banks are merging. Like recently, you had this Kotak Mahindra Bank and ING Asia Bank merging together. A lot of customers of ING Asia are also customers of Kotak Mahindra. How do you identify them? So there are different ways. You have bank number, you have the name is not the same. So if I given my name as B and Rajesh, one place, another place is Rajesh and B and so on. So how do you identify that the different names stand for the same person? So different techniques for the artificial intelligence systems. And they have very high reliability also, 99% accuracy. Okay. So other things are like basically internal capabilities. You have to train your human resources, and basically people should trust this, the insights coming out of this, and they should not be afraid of making a decision based on this. Right? So that is very important. So that is why the training of frontline employees is important. And then other kinds of issues which come. Who owns it? Which department owns it? Who is the custodian? Whom should I go for if there's a problem with it? Like what are the privacy and security issues? Some of them are governed by the government. So in many projects, we cannot take the data out of say Europe because there's a strong data log. We have worked on a remote center, log into the system and work. And of course, relationship with customers, business partners. So what kind of data will they be comfortable with? Analysis is difficult. So these are some of the implications. So I will stop here. So thank you very much for giving me this opportunity. If you have any questions, please feel free to ask. I'm here today and also tomorrow morning.
Yes, I do from different places to places. Different. Can you give us some idea what is the typical cost of this type of software and whatever project you have done?
See, the cost, you can do it for free actually. Because they are open source. The cost, the thing is not the cost, it's in the kind of skills you require.
No, but you provide the skills, right?
Yeah,
You make this free software and
you provide skills and you can, so typically say about a 3 months project, it costs about 5 to 8 lakhs, depending on, it depends on where you work, whether you are working at a client place or whether you are doing remotely, what kind of infrastructure you use, what is the amount of data which you are going to do. Right? Software is, the infrastructure is there, right? You need machines, you need nodes, so that will cost some. You need a connectivity, that will cost some. So it is not completely free, software is free.
so if you require different type of machine is what same computers will not work.
Same computers, but capacity, this is a big data. So you need additional machines. That will cost. And even if you are using a virtual machine, right? So suppose you have a big server, in which you can partition it and use virtual machine. Even then, it will have to occupy some your asset. So it will have a cost.
So in this project means how much big storage?
So I will tell you about this what we did here. This we were about a team of about 3 to 4 of us, having skills in, one person has skills in the accessing the database. So he has basically data analyst, and another person has skill in analytics, and so one from the domain side. So this we have an advanced group side, we have a lot of knowledge in there, so and this took about 3 months. Because understanding the data itself was quite. First, finding out the connection between the flight database and the maintenance database itself took it out. This was just a proof of concept, showing that this kind of analysis is possible. Because even though you can do, there is still resistance from organizations to adopt this technology. So you have to kind of start with a small project, show that it works. Once you show that it works, then only people will have confidence. They can go for bigger. That's the kind of typical roadmap. You were saying.
I was asking whatever you suggested, whether it can be implemented in house without any expert help. Is it possible? Or is it necessary to hire some expert help from us?
At least one person, because this analytics, I was talking to people, and they have not, even at the college, they don't have that subject. So for that, looking at these algorithms. But choosing the algorithms we need a person. And running it, other things can be done. This will come only from the knowledge.
See, you might have done it in many places. How satisfied were the customers after completing all these 2 months, 3 months, or 6 months job? Because it is, those data are also continuously.
Yeah, they just change. So what you have to do is keep on refreshing the models. You cannot stop with this. Right? So if you are this, you develop the model, you have validated the model, you implement the pilot scale, then you have to come back and recalibrate it if some of the ground stations have changed. Sometimes the environment will change, which means the marketing model will not work because the customers have changed. Right? So typical example is the customer aging. So if your customers are college students today, tomorrow are not college students, they are become someone else. Somebody else has come as college students. They have different, tastes, different desires, etc. So you have to do a different data analysis, and the models will change. You have to change you have to recalibrate it. Sometimes you have to change the model. So this is a continuous process. As you keep on developing it, your accuracy, etc., keeps on increasing. If you look at if you follow this recommendations from say 2000 or so, 2004, 2005, and today, the quality of recommendations we are getting today is much better than that we are getting in 2004, 2005. Primarily because one, they have a lot of data, and they have kind of segmented the database so much that they have personalized the recommendations. So which is not as you do it unlike a physical machine. You cannot stop with one set of models. It has to be defined. Does it answer your question?
Partially.
How many automation companies are using all this big data systems? Like APP or with the control systems?
They do use. I was looking at some of those reports that are coming out, and many of them is now slowly turning into. They talk about Internet of Things and industrial Internet of Things.
Will you skip that topic?
Yes, because it has already been mentioned, and there's a paucity of time. So, this industrial Internet of Things, what we are doing is basically marrying these technologies. Sensor is able to pick up data, you have Wi-Fi connected, sensor is going to send you the data, and you have to actually process it and send back results or show it in a monitor and so on and so forth. So that and configure, reconfigure and so on and so forth. So that itself is a very big problem, which I am sad to say that I am not experiencing.
The existing AI solutions are not able to commit this.
They will not be able to do it. They are being sad and not
Providing some kind of solutions.
That is, they are not going to something of SAP HANA, which just touches the surface. It doesn't go deep into this.
They were saying that they have implemented this thing very successfully.
Well, yes, some kind of marketing. See, the biggest company is SAS.
The last example they had given of the Saudis transportation system. They have implemented the very successfully, along with the essential.
They must have, but this would have not been so complex. The model is built may not be so complex, but we must just starting the primitive models which take you one step further. What I am talking about is something which is looking at many of these algorithms and automating them. So that, like a recommender system, things like that. That's as cannot personalized recommendation. So you have to actually build it on top of it. SAP cannot do it. You use SAS or something else and build on top. And many of the companies don't use actually SAS. They actually do it on Java, Python, and other kind of programming languages because they need a response, fast response, which is not possible if you are using off-the-shelf computers. It's like you have microcontrollers, microprocessors, PLCs, which have specific programs which are optimized for that kind of job. Am I answering the question? So if there's no other question,
You can talk even dinner also.
Yeah. And I thank you all for being
Thank you, Dr. Rajesh. Nicely covered latest studies in IT, latest trends and technologies, and from the beginning until now what is going in the future also, and practical applications. New words you have most of you may not know in those technologies also has covered. Actually, the session is just more than a 3-hour session. Okay, he has convinced it and I said given, and he has accepted that he will be sharing his slides to us. We will be giving our views in a separate pen drive. You can read those slides. And now I request Mr. Vastaji to present a monologue to your audience. Sir, today we are calling this day for this program, but dinner is there. I request slide we are just 15 minutes delegates open no problem. Now I request all the delegates they can if they want to they can go back to the hotels and then come back. We have for dinner will start by 7:45 schedule. Now 8 o'clock will be ready. Please make a point that by 8 o'clock will be here. We have just 200 meters from here. We have guest house where our dinner will be held there. And those who don't want to go to Niagara, they can right now they can go back to the guest house. We have TV lobby is there. Everything is there. We can enjoy that. We can have soft drinks also that can be available here. And those who want to go at the restaurant, it's up to them. But being a culture, it is not just a dinner. It's a lot of fun is there. You will be missing if you are missing a dinner. And we wanted to it's a cocktail dinner again. Why the cocktail items in the brightness of the bread? Please join the dinner. There is a lot of fun today. A lot of people missing. A lot of experience right now in time so that we can enjoy more time in the dinner. And after dinner, again you can go back to the photo. And about the tomorrow, 8:15, everybody should be in the hotel lobbies. After having a breakfast, and 8:30 bus starts from there shortly, and 9 o'clock the program is starting. Please come here, and we have a lot of things to do tomorrow. And my request to all of you, those who have brought their presentation, they kindly hand out to us so that we can schedule the presentation as well as schedule being given to everybody. We are not taking any schedule; it's going as per the sequence on the fairway. Please make a point that this will be followed. Okay. Thank you. Thank you very much. Buses are available right now on the roadside.